Hello all, welcome to the subject of microcontroller. I am Professor Meenakshi Pancha from Electronics and Telecommunication Department, Parvatibai, Canva, Mojay College of Engineering, Voguli, Pune. So in a previous lecture, we have seen how to interface this DAC 0808 with a microcontroller. So we have also written the program for how to generate a triangular wave. Now today we are going to see how to write assembly language program to generate a sinusoidal wave generation. For sinusoidal wave generation. So we need to calculate the value for the sinusoidal wave in between 00H to FFH. So this is done by the following table, and here we have, I will see the table in the next slide. So I will see now, just a minute. So I will show how accordingly that the wave will be generated. So this is the table. Here, what we have did here, we have divided the entire cycle of 360 into 48 parts. So each of incremental 7.5 degree. Hence the angles are 0 degree, 7.5 degree, 15 degree, 2.2, 22.5 degree, like that. What will happen here? Divided the degrees into 48 parts. Here the total 48 values shown in a table here. There are 48 data, and we cannot have a negative voltage in the output of the microcontroller. The sign for hence the sign 0 we need for the output, it will be center of, that is 2.5 ohm. So trending is, it is the x-axis, hence we add 2.5 volt to every calculation as seen in the fourth row of the table below. So then we find the corresponding value for each voltage by multiplying it with the maximum count and dividing it by the maximum voltage. So as given in the fifth column of the table. So if you still reduce the step size from 7.5 degree, you may get a better waveform. And for the program in the assembly, we have to take an angle at the interval of 30 degree, and this gives the less accurate output. So let's see the main algorithms program how to write. First we have to make step 1, initialize the data according to the above table. First we have to initialize our data according to our table. Then step 2, issue the data one by one from the array. Then repeat the above step continuously to get the continuous waveform. So these are the steps we have to perform while writing the code. We have to keep it in mind. First step, let's see. What is the first step? Initialize the data according to the table. Initialize the data according to the table. Then second step is issue the data one by one. Issue the data one by one. Issue the data one by one from the array. The third step is repeat the above step continuously. Repeat the above step continuously. So let's start writing the program. I'm going to start from here. So first initialize the memory location org 000H. Then next LGEM. Start Then ORG 0100. Then start is from here. So what should we do? First move in the register or not with the value hash 30H. So data according to the table above, we have to initialize the values. So what will happen here? We are loading the register R0 with the immediate value 38. So this is the address we are storing into the R0. Now, according to table, the first value is 128. What is the first value? 128. So we are going to loading the data move at R0. Move at R0. What we are going to loading here? The value 128. 128. This is the table. This for the sinusoidal wave 360-degree. Here they are divided up to 48 values. So at particular degree, so they are given a count. So we are loading this table here. And after that, what should we do? We should increment R0. Increment R0. Increment R0 is nothing but, what is a R0? R0 is 30H. So now R0 will become 31H. This is the memory. So now R0 is 31H. And after that, what we are doing here, we are again loading the value according to the table move R0, move at R0. Move at R0. Nothing but what is the address present in R0 at that particular memory location. We are loading this data. So next data is 192. So according we have to give here. So this data we are loading. So according to that, we are going to loading here. The some following step gap we are taking to adjusting the size. Now let's see what happened here. So after moving the data into the memory location address present in at the R0 register. So for that we are going to writing the code move at the rate R0 comma hash 192. So similarly we have to increment R0 again. Then we have to move at R0 comma hash 238. So according to that, these values are loading into the register, then again increment or not. So according that the output waveform will be generated. Move at the or not, comma hash 255. Then again move or not, increment or not, sorry. INC increment or not. So we have to load a different values to 38. Then after incrementing, Control V should be load 192. So according to that, we can load any value provided in the table. So according to that, the sinusoidal waveform will be generated. So after 128, 192, we have to load 128. Then again Control V. So 64. Then Control V. 17. Zero. INC are not move at are not comma hash 17. So like this we have to write the program. INC increment again are not, Control V, move or not, or add the or not. Add the or not, we have to load the value hash 38. So after completing these things, we have to load again the value 38. Then we are writing loop here, the name here, and move P1 comma at R0. What is the R0 present in? It should be move into this R0. Then INC increment R0 again. Then compare jump not equal to R0 value to hash 3CH to here. So here we are going to comparing. If the last data is issued, then repeat the procedure from the beginning. So it's nothing but. Then move R0 comma hash 30H. Then after that S jump to here. Then we are going to finding the program. So this is the simple program we have written for generating the sinusoidal waveform at the digital to analog converter output. Now let's see how to generate the waveform. Trapezoidal wave generation. See in the slide, this in the figure which is given. So this type of wave generation we have to write a code. So there are a few steps how to keep it in mind while writing the program. So for that, first we have to initialize the port 1 pins to 0. Port 1 pins, all the port 1 pins first make 0, then increment P1 till it reaches FF. The same procedure we have seen in a while generating this first the triangular wave. So increment the data in P1. Increment data in P1 till it reaches the value 0 FFH. So after that, the small software delay we should call delay. Then after that, once it reaches the maximum decrement, the data in a P1 till reaches 0, 0. Now we should decrement data from P1 till 0, 0H. Then again we have to call a delay. So like this we have to write a code. So let's see writing code. First we have to org initiate the memory location. This is H. Then after that L J MP LGM start. After that org we have to write from 0100H. So very start begin start from is here. So what should happen in start? Move A comma hash 00H, because we have to initialize the port 1 pins to the 0. So after that we have to write a program move R7 register comma hash 0FFH. So after that what will happen? I am holding the highest number from till that the port 1 pin should be reached by incrementing it in a step. I am holding the high value at R7. Then after that we have to decrement jump non 0 to R7 at here 1. So where is here 1? Here 1 is hold this value for delay. For delay purpose, what we are doing, decrementing whatever the data present at the R7. If they are not 0, whatever the data present in R0 is not equal to 0, then what should do? It will go to year 1. So where is year 1? Here. So this will keep executing the same process until the R7 will become 0. Now this is a delay. This is written for a delay. Now we are going to writing code for initializing the port pins here. Move P1 comma A. What is the data inside P1? Here, this one is 0, 0. So this one is 0, 0. Now 0, 0 is loading into this P1. Again, we have to increment. So INC A. See, here first step we have, what we did here, we have making all the P1 to 0. Then its second step is we should increment the data. We should increment the data up to what value? Up to 0 FFH. So for that we have to write instruction compare jump not equal accumulator value present inside the accumulator to hash FFH, or we should write 0 FFH. It will increment here after loading the data A into P1. Now P1, all the P1 will become 0. Then after that I have to increment accumulator A. Then I am comparing A comma 0 FH. If they are not equal, jump here 2. So where is the sorry, it should be jump to again. It should be jump to again. It will decrement and load the value present into the port 1 and then increment again check. If it's not equal to both are same, then it will go to again. The same procedure will be continuing here. Then after that, if both are equal, the value present in accumulator is equal to this 0 FFH, then what should do? Will execute the next instruction. What is that? Is move R7 comma hash 0 FFH. We should call the delay. We should call for delay. So we are loading delay purpose the R7 with this value and decrement gem non-zero of this value present inside in R7 to 0, R7 to 0. Then start executing next instruction. If non-zero, then it will move to here 2. So where is here 2? Here 2. Start again from here 2. This is here 2. This is a delay function once again. After, now what will happen now? Our port value will reaches to highest value 0 FFH. Now we should make it to decrementing till 0, lowest value 00H. Now we are loading the port 1 comma A. What is the data present inside the accumulator will load into P1. Now A P1 holds the highest value 0 FFH. Then we should start decrementing A accumulator up to what? Decrement, sorry, compare jump not equal the A with the value 00H up to NXP. If the value, it will decrement the accumulator, then check if it will reach to 0 or not. If it is not 0, then go to NXT. So where is the NXT? Next is here. NXT. So it will. So if it will decrement by accumulator, if it's not 0, then go to NXT. NXT, whatever the value present in the A, after decrementing whatever the value holds A, it will move load into the P1, then decrement the again. Then it will check and the same procedure will be continued until the A value is equal to 0, 0, H. After that, if both are values equal, then it will jump to here. It will jump to here to continue the same operation. Then this is the end. So this is the short program written for the generation of trapezoidal wave generation. Here shows in a figure. So for that, these are the very easy and simple. First we have to keep it in mind the steps. So according that we have to write the programs. So interfacing digital to analog converter is over here. So in the next lecture, we are going to see interfacing of temperature sensors LM235. So how we can interface this temperature sensor, and next one of that is interfacing stepper motor. So few topic is left in this third unit. Then after that we have to see some problems. So this is enough for the day.